Hey everyone, it is me, Steve. It is March 26, 2019. Time is about 12:13 CDT. It's about 47 degrees Fahrenheit out, and it's Geo-Rant time. This is Geo-Rant number 97. This is going to be the first of three. It's going to be about this book, since I have a hard copy of it. The next Geo-Rant will be about, this is for Igneous rocks. The next one will be for sedimentary rocks, and it's green, and then Geo-Rant 99 will be for metamorphic rocks, which is blue. The reason why I'm doing this is because I want episode 100 to be something special. I want you guys to ask me questions, and I will answer them to the best of my ability. I want to make it a special episode because, quite honestly, these Geo-Rants, people do watch a decent amount of these, more so than like my Geophiles episodes, which are more technical, or even my field stuff. And I got a good field video coming out. We hiked Baraboo on Sunday, and I got a Baraboo, Devil's Lake specifically, video coming out. So that's in the works right now. I want 100 to be special, and these Geo-Rants are originally just meant to be filler on my channel. Like if I go 6 or 7 days without, or even 4 days, 3 days sometimes without posting something, I'll do one of these real quick. And the reason why is so I can keep people knowing that I'm not, my channel is still active. And I like to share the short knowledge with you, and these are supposed to be short. This one's going to be a little longer because of this intro, but I generally try to keep the things under 10 minutes. All right. That's the point of a Geo-Rant. Anything longer than that would be a Geophiles episode and would be more technical in nature. And something in this book was inspired by a typical rock hound. He lives in Ontario and he goes out looking for mineral resources. So what I did for you, buddy, in this book is on Amazon. I'll link it below if I remember. It's like $14.75. It's in color. Gold versus pyrite and chalcopyrite. Feel free to screenshot this if you want. These characteristics are what I could find going through the interwebs and in the printed literature to distinguish gold from pyrite. And I know pyrite's called fool's gold, but it's not an insult to anyone's intelligence. Pyrite itself is kind of easy to differentiate from gold. Chalcopyrite's different. And so you need to be able to, this should help in the field, at least out there. You could sit there and you could be like, oh yeah, this is definitely chalcopyrite, I'm not picking it up. So that's the point of that. But that's only appears in the Igneous book. But this book itself basically deals with igneous rocks. You basically have two groups of igneous rocks when you go to classify things. This book is not a teaching guide. All right, it assumes you have a decent grasp of earth science and specifically geology in order to, or have some experience actually classifying rocks. I don't say you had to take classes because the literature's out there to compile something like this, quite honestly, at these days. But here it's in one place. So you have two main kinds of igneous rocks. You have what we call plutonic or phaneritic or coarse-grained. Those would be your granitic rocks. That would be the ones that, let's see here. That would be the ones that look like, I'm going to try to not have a lot of dead air here. That would be these type of rocks, okay? Those are your plutonic. Then you have your volcanic or aphanitic or fine-grained igneous rocks, and those are referred to as volcanic. When I'm talking about magmas, I'm going to use the word melt because magma is used for melted rock that's underground, and when it comes to the surface, we call it lava. But guess what we call lava that has solidified in a rock? We call that lava. I know, it's annoying. So if I'm referring to magma or melted rock in its liquid form, remember, melted rocks are not minerals. Magma is just a chemical concoction. You have to be solid to be a mineral. I'm just going to refer to it as melt. Okay, just to keep it simple, because quite honestly, there's no reason for the distinction between having it on the surface and underground. It doesn't mean much of anything. It's neither here nor there. The book does have some, so you can get relative grain percentages. The book is in color, but there are some black and white parts. Bones Reaction Series is in here, but it's in black and white because that was the first one I did before I decided to make this in color. These pictures, all my pictures in here are pretty good, except for these for some reason. I don't know why they turned out bad. These are from when I was at the Seaman Mineral Museum, and this is Sodalite, or not Sodalite, this is Uperlite, and these pictures just look really bad. I'm hoping it's just this one printed book. But the others look good. Like, this looks really good. This is a gabbro I've been polishing over the years. I like the way that turned out under microscope. And I go through here and how to, you know, because when you're trying to classify things, you're going to use a QAPF diagram, and you're going to either use the plutonic or the phaneritic or the aphanitic one. And you have this here. Okay, it's your QAPF. Your basic parts to any igneous rock are going to be this. You're going to be your mafics, which tend to be your dark minerals, your olivines, your hornblends, things like that. You're going to have your feldspars, which will be plagioclase and alkali feldspar, which you're going to have to be able to differentiate, and this book will show you how to do that, okay, in order to plot them on this chart. And then you are going to have quartz, okay? So if you have quartz in your rock, you're going to use this part of the chart. If you do not have quartz, you're going to have foids, so you're going to use this part. So you have your mafics, you have your feldspars, and you have your quartz/foids. Quartz and foids will not form in the same rock. As a magma cools, if you have a foid, quartz will not form. That silica will be used. It's a physical impossibility. It's like trying to take, it'd be like trying to take, I don't know, maybe a block of lead and a block of copper, pushing them together and expecting to get salt out of it. That's not a great analogy, but you get the point. You can't force these things together. You can't force them to form together naturally, okay? So, in the aphanitic or the fine grain, the volcanic rocks, there is also a very similar diagram, follows the same pattern, except it's a lot simpler because unless you have detailed chemical analysis, can actually get the chemical makeup of the rocks. This is about as good as you're going to get. I do not have a what's that diagram, TAS diagram in here, because you need chemical analysis for that. But this book will show you how to divide those, hopefully in a usable way. But you got to remember, when you are using those QAPF diagrams, you have to normalize twice. These do not function like normal ternary diagrams, and I walk you through the process. If you use the QAPF diagram, you are going to disregard your mafics. You do not include them in this, and that's the point of using the QAPF diagram. If you notice, there was no mafic part, all right? But if the rock is made of more than 50% mafics, and they can very well be more than 50% mafics, you are going to use something like this, okay? All right, and this is not like the QAPF diagram. This olivine and anorthosite can be in the same rock. This just means the two butt up together here. There's actually another part of this diagram that is irrelevant to the Midwest, that if you fold them together, you would get a pyramid type thing with three sides. But that wasn't included in here. It wasn't necessary, and I explained that in here. So, trying to find out what else is in here. We have normalizing. I went over that. I went over the gold. Oh, Bones reaction series. Just real quick, crap, we're coming up on 10 minutes. Try to get this started. I've shown you this before, continuous, discontinuous, and this residual. And the good thing about this is, as a melt cools, it will, like your continuous series, what happens is your plagioclases will be calcium rich, and your calcium ions, as the mineral forms and then this magma cools, that's unstable. Calcium gets swapped out for sodium and then eventually potassium. That's how you get your alkali feldspars. The discontinuous series is different. It's more of a restructuring of the internal structure. And then you have your residual, which is just what's left. Now, the reason why I'm bringing this up again is because not only do minerals form in this series this way, they weather in this series. These minerals up here are very unstable on surface earth environment. Quartz is very stable. Quartz will not naturally react with anything. It mechanically breaks down. It does not chemically weather. Everything else on here will to some degree. And you can use that to help identify your rocks. And I actually go through that here. If you look here, you can see off on this side, the red means, you know, weathered, and the green sticks out. You can tell your mafics. You can get a good sense of which mafic minerals these are just by the weathering pattern. And I show you how to do that here, okay? But anyway, if you want, get the book. If you don't, that's fine. I have a lot more interesting books out there, roadside books. By the way, before this becomes 10 minutes long, that's it. Have any questions for Geo-Rant 100 coming up? Hopefully, I will have that sometime next week. But I got to, like I said, I just ordered the other two author copies, so those have to come first. But anyway, that's it. Hope you learned something. Leave a comment.